okay if you draw the arrows and just show the math, especially, like, you don't need to show this, but I just like it in your notes right now, just to show our thinking. Either the inside is positive, or the inside is negative. And those are the two different branches that we have to solve for. The positive one is the easiest, because then, if the inside is positive, it would just equal itself. Like, the absolute values are not necessary if it's positive. But if it's negative, and this is where I'm going to put an or here, you can either do this, right, just like we did in the last question, put the whole thing in brackets, and a negative out in front, because if the negative 3x minus 2 squared plus 4 is negative, the absolute values would make it positive. Algebraically, how do you make something positive? You take the whole thing, put a negative in front, because a negative times a negative would make it positive. However, in this situation, since it's just a number on the other side, we could also just put the negative on this side. And I like that better in this situation. I don't have to worry about distributing. Does it make sense that if it's going to equal 4, if the inside is negative, the inside has to equal negative 4? That's the only way that the absolute values would make it positive 4. Now we can solve. Subtract 4 on both sides, that makes this 0. And for solving this, I would use the completing the square solving technique, because the square is already completed. So you want to get what's squared by itself. So I would divide both sides by negative 3, that's still 0. And once you have what's squared by itself, how do you get rid of a square? Square root both sides. Just because I want to practice the habit of remembering plus or minus, I'm going to write plus or minus 0. That's both zeros. You get that, right? There's no minus 0. Like, I have nothing and it's really negative. No. But now I can just move the x over. Super easy to get x equals 2. That is a lot easier than multiplying this all out and trying to factor it, or use the quadratic formula. However, that is possible. You're not necessarily going to like how much work this other side is, but I'll show you the completing the square, because I think it's the fastest. I'll also show you the quadratic formula, but I don't think it's quite as nice. So first of all, if you want it, the square is already completed, so if I can get this all by itself, I could square root both sides. So first I move my 4 over, like terms, and divide by negative 3, which makes it positive 8/3. And then I can square root both sides. Remember the plus or minus, square root of 8/3, and this side just becomes x minus 2. To get x by itself, you would get 2 plus or minus, and square root of fraction, I can write that as 2 separate square roots. And if you were already in grade 12 AP Calculus, they'd be like, perfect. You get 100% now, you've written your final answer. But in grade 11 math, we still have to follow by the rules of having to write our answer in the most simplest form. And so you have to remember that simplest form does not allow square roots on the bottom. So we have to rationalize the denominator. So if I do that, I would have to multiply top and bottom by the square root of 3. Okay? So I get x equals 2 plus or minus square root of 3 times square root of 8 square root of 24 over 3. And in grade 11, you have to write your answer as a single fraction, and this is right now 2 fractions added and subtracted together. So we need a common denominator, which means I have to multiply this by 3 and 3 to write 6 plus or minus the square root of 24 all over 3. Now we've got a single fraction. But we also have to remember from grade 11 that you have to write your radicals in lowest terms. And the square root of 24 can be simplified because 24 is 4 times 6, and the square root of 4 is 2, so this becomes 2 root 6 over 3. I might be tempted to simplify the 6 over 3, but I can't because I'm adding and subtracting, right? I could possibly factor the top. I could factor a 2 out of the top, only to realize that it doesn't simplify with the 3 anyway, so both of those would be considered final answers that are fine. Either the factored form or the non-factored. And I think this is the easiest way to do this question. But it involves a lot of review from our previous units. Option 2 would be, I'll do option 2 in green from this spot. Let's say you combine those like terms. Oh, I said green. That's still black. There we go. Minus 8 equals minus 3. And you could multiply this out, giving you x squared minus 4x plus 4. Then you could distribute your minus 3. Negative 3x squared plus 12x minus 12. And it's a quadratic equation. How do we solve quadratic equations? We make one side equal to 0 and factor or use the quadratic formula. Or complete the square, but I'm not going to do that because that's what I did over here. It would be kind of like redoing what I just undid. So I'm going to move everything over to this side, 3x squared, and subtract my 12x. And add 12 will be plus 4 equals 0. It does not factor, so I'd have to use the quadratic formula. Negative b would be 12 plus or minus. B squared is 144 minus 4 times a times c over 2a. And we get 12 plus or minus the square root of 144 minus 48, 96 over 6. But you'd still have to simplify this. And the square root of 96 is 16 times 6. And then notice that each of your terms can be divided by 2. So we get the same answer. What makes the quadratic formula, I think, harder here is it's harder to simplify the square root of 96 compared to the square root of 24. But you didn't have to rationalize the denominator. So you'll notice a lot of things get brought back. There's going to be a lot of graphing stuff that gets brought back in this unit. Here we had our rational stuff and our radical stuff get brought back. Questions for practice that you can circle on this one. Or 11 and 12.